All right, cool. Well, good afternoon, and thank you so much for coming to this session. George was unfortunately not able to make it. He's based in London now, and so if you have any questions afterwards, feel free to email me, and I'll loop in George. We'll be able to talk about any questions that you might have. But my name is Ted Wei. I'm a program manager on the Azure Machine Learning team. And so, any of you familiar with Azure Machine Learning? All right, cool. Anybody? Okay, so you're familiar with it. Anybody used it? Okay, cool. Okay, so we kind of got a couple of people, most people who are familiar with it and have used it. So really just talking about the general Internet of Things and how that might be applied in a manufacturing context. And so today is really just an introduction to the platform components of the Cortana Intelligence Suite, how you would be able to ingest data and process the data and then be able to deploy those solutions so that you have your data ingest and your data processing and then running a machine learning model on that to address specifically early failures from a manufacturing perspective, and then using machine learning models to be able to do those kinds of predictions, and then how Power BI can be used for visualizing those types of component failures. So specifically from a discrete manufacturing perspective, really just the digital transformation, I'm sure as you're all very aware, right? So I'm just curious what kind of industries are represented here. Can you just kind of shout out? Entertainment industry, okay. Higher energy, yeah. Insurance and consumer packaging. Yeah, first products. Okay, great. So I think a lot of people are, you're knowing that this is, we're in a very transformative stage right now to be able to do that, and I'm sure you're living in the midst of it. Everything from R&D to be able to do product innovation, and then from a production logistics and marketing and sales. And so we're going to be focusing on just the production perspective, where you have the basic idea is you have the data that's coming in, and then being able to process that data, and to be able to do things with that data and what that would look like. So quality in manufacturing, obviously super critical and important. Statistical process control, Six Sigma. There's a ton of things that are out there already, right? We're not reinventing the wheel, but it's about what can we do now with the tools that we have to be able to bring advanced analytics to the manufacturing process. And so with quality, I think this should be blatantly obvious to everyone, from reducing scrap and rework and being able to save on costs. Like no customer wants to get a poorly made object, right? A poorly made thing. And so how do you increase the customer loyalty and gain new customers? And so the main impetus behind this is to be able to predict when in the process things will break down, or when in the process things will fail before it gets further down the line in terms of quality control from an assembly line perspective. So Jabil is a company that we work with, and they are an electronic parts manufacturer. And so basically, you're probably familiar with like circuit boards and things like that. And they have basically they have an assembly line that you're probably familiar with. And at every stage of the process, failures can be introduced, right? So each stage, you have things that are done at each stage. You have tests that are done at the end stage, and then so you might not detect it until the very end, right? You're building something, it's going down the line, and then you do a final test on it, and then it's actually fails, right? That's a big problem. And so what Jabil was facing was that they needed to increase yield, right? Given everything, I'm sure they've tried everything they could. How do they increase yield? How do they use their they have their traditional inspection techniques for ensuring quality, right? That was quickly becoming outdated. And because you have all these various processes, and having to update all of that is very difficult. And you can't just throw more equipment at something, right? You might need to reconfigure something quickly, and you have to put all the testing infrastructure in place too to be able to test things. And so it's a very, very costly process to reconfigure. And basically, when you have failures at the end product, obviously you have your manufacturing cycle time increase because you're not producing as much product. You have wasted materials and time and resources. And then obviously, if your customer wants something, it's hard to get that into market if things are failing on the production line. And so what they wanted to do was to be able to better predict errors in the assembly line process. And so the Azure services that they use to be able to do the data ingestion of the things that they're already using. So it's not about, throwing away everything they have and trying to build up something from scratch. It's about taking the data that they already had, being able to collect that data and process that data to do the prediction. So how they were able to do it just using the Cortana Intelligence Suite is basically the main point of this talk. What they were able to do was they were able to predict machine processes. They were able to predict it with 80% accuracy of failure, reducing the cost of scrap and rework by 17% and delivered energy savings. So really just the motivation for the importance of being able to have this in place to be able to make better decisions. And obviously from a quality assurance perspective, when you're able to improve product quality, your customers will be more satisfied, reducing costs and downtime. And then you have the real-time analytics that people can look at. Are things failing in the middle, informing people of equipment failure, increasing that speed to market, and diminishing scrap and rework. So I'm going to do a quick overview on what a solution like that might look like. So the Cortana Intelligence Suite is just our suite of services that you could use to build your end-to-end solutions. Cortana Intelligence Suite is just a marketing term. And think of that as something like Microsoft Office, right? You have all these various PaaS services that you can spin up. You're here for a Data Insights conference, and so Power BI is right there at the end where you can visualize the data. But the entire pipeline starts with the data that you have. So at each step of your manufacturing process, you might be emitting a lot of data. Your factories might be connected to a lot of various sensors, and so that data could be ingested using something like event hubs. So event hubs are, I don't know if you're familiar with Apache Kafka. That's kind of like the Apache Kafka equivalent, where you're ingesting millions and millions of events per second. But the nice thing is that it's a PaaS service. Go to the Azure portal, spin it up, and it's doing your data ingestion. From there, you might be able to, from like a hot path scenario, you might run it through Azure Stream Analytics. Azure Stream Analytics will then do your near real-time data processing. So you might be aggregating data. You might be doing a lot of other things with the data so that the output of Stream Analytics can then go into an Azure machine learning model. So an Azure machine learning model is just a model that will take in data, run it through, and then be able to output a result, and it's exposed as a REST API. So if you have an existing data pipeline where you're collecting data from your manufacturing processes, you don't need to scrap it all. You can have that data, send it to a machine learning REST API, and then be able to get that response back. So you have your hot path. Those results can then be shown on something like a Power BI dashboard. So people who are working either on the floor or people who are working in various offices can look at the various products that might be predicted to fail, and then be able to take action. Maybe you might want to scrap it early or to rework it so that it doesn't go down the line. So that's your hot path. Your cold path would be something like taking in that data and then putting it into something like a data lake or blob or HD Insight, and then you can do your analytics over time. This is your batch layer. So this is then you can look at all your factory lines over the past 6 months or over the past year, or look at all your lines across the world, for example. So these are just the various components that you can spin up and have them work together. So we do have a quality assurance and manufacturing solution on Azure. This is, I'll show you in the Cortana Intelligence gallery. It's basically a template that you could use to start playing with this solution. The Cortana Intelligence gallery is just a collection of templates, such as Word. You have your resume templates. For Excel, you might have your budget templates. This is a template that has a synthetic data generator. Event hubs are set up and deployed that will listen to the synthetic data generator. That data is coming in. It's being processed. It goes through Azure Stream Analytics, where it's being processed in near real time. And then it goes through a machine learning model where you get a response back. And then you can show the result on something like Power BI. And this is basically the architecture of what that means. So the important things here, one thing to note is that, again, these services can stand alone. So you have data that's already being emitted by your factories. They can be sent to an Azure machine learning model. If you can send it to a REST API, you can send it there and get the response back, and then you can take action based on that data already. You don't need to create this entire new pipeline. But if you want to create the pipeline, then it's also very simple to stitch up these solutions together. So basically, now I'm going to talk more in detail of what was happening with Jabil. So Jabil, they do electronic components, and they have a lot of contract manufacturers. So they have contract manufacturers where each one of these steps, these assembly line steps, they had, for example, an example of a step would be, you start with a clean circuit board, and the first step might be putting like a drop of solder on it. And then you might have a test there. Maybe you might look at the height and the width of that drop of solder. And then that would just go down the line. And at each step of the process, they were emitting data from there. And then they might be taking components from various contract manufacturers. Those components are then doing final assembly. And what they were finding was that at the assembly line step level, they were passing their tests, right? At each step, the tests were passed, but then at the final stage when they were doing the functional test, it was failing. And then basically based on the data that they have, they know the devices and they know which devices passed or failed the functional test. So this is starting to get into your classic example of supervised learning. You have the existing data that's coming in from each step, and maybe based on those steps, you're already thinking that everything was passing, but then it failed the final functional test. So what we did was go back to the individual steps based on the data that we have, and then build a machine learning model with this step. So this is really just at the end of the day what happened. So we know which components passed or failed. We know the data that came from that step. And then we build a machine learning model so that in the future, things coming off that first step, we would then run through the machine learning model, and then we get a prediction as to whether it would fail the final functional test. And so the whole point was finding where we have the ability to collect the data and then build the machine learning model and then be able to put it back and do the predictions. And then you can basically put machine learning models wherever you have data. So with Jabil, they didn't have to do anything with their existing pipeline. They didn't have to break anything down. They didn't have to add additional sensors because their sensors were already collecting the right data. It was just a matter of taking that data, running it through the machine learning model, and then putting that result in something like Power BI. And so again, this is just kind of the solution design summary, but they have their assembly line steps, their list of failures were able to be used, and then you can work with your subject matter experts. And again, this is kind of the whole process, right? So your manufacturing pipeline today, your manufacturing line, where's the data? Where's the data that's available? And what's happening at the very end? And then how you could send that data to a REST API and then run the results and show them so that the right people who can make the right decisions can do something with it, right? That's essentially the strategy of how you might want to implement this in your production line today. And so I'm going to do a quick demo on Azure Machine Learning and talk about the data science process. And so I don't know, was anybody in the previous, I did a previous session like at 1 o'clock. Were there a few? OK, so there are a few people there. OK, so I apologize. I'm going to just spend 5-10 minutes on things that you've heard. But if you don't remember, then if you were kind of falling asleep after lunch, then this will be a refresher. So the data science process is really just a systematic way, a framework of thinking about the approach to data science, right? Where you have data and what you'll do with that data. And so in this case, our end goal is to try to predict if something is going to break down, right? So after assembly line step 1, I have data. I'm going to try to predict if it's going to fail the final functional test, right? So that's my objective. Is this going to fail or not? So the output of my machine learning model would be a 1 or 0, if it's going to fail or not. And then the next step is to access and understand the data. What data do you have available already? So which data set do you have? And then doing the pre-processing. So I mentioned at the last session, machine learning, very exciting, data science, super sexy and super cool, but you know that's only really about 20% of the time you'll be spending on it. 80% of your time is going to be in data collection, data cleansing, feature engineering, ingestion, all that stuff that nobody really likes to do, but is super critical to building a good model. So that's the time that is really critical to take the data that you have to be able to put it into a right state so that then you can finally run it through a machine learning model. So once you have that data, you can then build your model and train an algorithm on that model. So the example that I like to use is when you are training an algorithm, it's kind of like being back in college and going to a final exam. Right? So let's say I had 100 questions, and out of these 100 questions, I'm going to pick 30 of them and test you on them at the final exam. So if I gave you all 100 questions, let you study it for a week, and then next week I pick 30 questions and test you on them, I'm expecting you'll do pretty well, right? You're taking the time to study them, you've seen these questions already, and you'll do very well. I don't know if you actually know the material or not, right? All I know is you studied these questions. So the honest way of doing things would be, I'll take 70 questions, I'm going to let you study them, and then have 30 questions that you've never seen before, and then I'll take these questions and test you with them at the final exam. If you do well on these 30 questions, then I'll have a better idea of how well you actually know the material. And so this is where the split, that's basically what's happening with this split. I'm splitting the data into my training set and my test set, and then I'm going to train a model on the training set, and then I'm going to apply that model on the test set. And if that test result looks pretty good, then I'm going to be able to know that the model actually works pretty well. And then once you have that model, you then need to deploy it and operationalize it. You need to be able to make it part of your end-to-end workflow where you can actually use the model and then be able to get a useful result, essentially. And from there, to be able to do your evaluation and then update the model as necessary. So maybe you have new data that's coming in. You know, your assembly line is still running. All the products are still coming down the pipe. You're gathering new data. Your machine learning model may not be as accurate at first, but then towards the end, you take this data and then you can update that machine learning model. So let's make this machine learning model a little bit more real. And so I'm going to start first with our Cortana Intelligence Gallery. So again, this is the gallery, our collection of templates. You can go to the Cortana Intelligence Gallery to be able to spin up a solution. In this case, you know, if you want to do something like predictive maintenance, let me see the quality assurance. So here's the actual solution that you could just go to in the gallery. So if you click deploy, this will deploy all the services that I just talked about. You'll have your event hub. We have a synthetic data generator, you know, simulating data that's coming from a factory line. It's going to be ingested by an event hub. It's going to be processed by Stream Analytics, and then we run a machine learning model on top of that, and then be able to predict whether something's about to break down or not. And now, with this solution already running on Azure, then you could just update your data. You might, instead of using the synthetic data, you have data that's coming in from your factory. You can update event hubs, update Stream Analytics, update your machine learning model. That way, you don't have to start from scratch and try to figure out how to spin up all these various services. So this is what you can do and get to a solution very, very quickly. So I'm going to do a quick demo of Azure Machine Learning. I think there are still some folks who haven't seen it before. And I'm not going to use the same demo as the last session. I'm going to use my favorite demo. I like to use the Titanic demo. Anybody seen the Titanic demo? Okay, a few people. Okay, so most of you haven't. So you know, it's kind of like the middle of the afternoon. I'm going to try to predict who would survive Titanic or not, right? And so rather than, you know, we've been talking about manufacturing the whole time. You all know, I've been beating it down your throats that we're trying to predict whether some components are going to fail or not. So to illustrate Azure Machine Learning, I'm going to take a data set of Titanic passengers, and I'm going to predict which passengers are going to survive. And so this is what that experiment looks like in Azure Machine Learning. So in the context of manufacturing, the idea is the same. I have a data set of about 900 passengers from the Titanic. I know who survived and who did not survive. I know that about 550 passengers did not survive and 350 passengers survived. I know whether they traveled in first class, second class, or third class. I know whether they were male or female, how old they were, whether they traveled with siblings or spouses, whether they traveled with parents or children, how much they paid for their ticket, and which port they embarked from. So the same idea, rather than Titanic passengers, the data you're going to have is, what are the sensor readings of the components that failed the functional test, right? What are the sensor readings of components that passed the functional test? So instead of survive or did not survive, it's basically pass or fail the functional test. And you can use the import data. So if you have all your data coming from your production line, if it was already in there, if it's already stored in HDInsight or Blob or SQL, you can bring that in as your training data using this import data module. So, so then you basically, each one of these modules is just doing something with that data. And for those of you who do R in Python, we can also bring in a Python script. And so in this case, what I'm doing here is the ability to be able to copy and paste in your Python code. So Python and R is basically, these are the languages of machine learning today. Any data scientist you hire out of school is probably going to have learned data science using R or Python, right? And so if you have any libraries, typically a lot of people have been putting stuff on open source on GitHub. You might have other manufacturers out there who've been doing some research into either predictive maintenance or forecasting or anything like that. They have some libraries on GitHub. You can bring in that code into Azure Machine Learning, basically copy and paste in that code and run it in here. Or you can just basically use any of these modules. So in this case, I'm just going to use a 2-class support vector machine. And again, I'm predicting whether Titanic's passengers have survived or not survived. But if I don't want to use a 2-class support vector machine algorithm, I can do 2-class logistic regression. And you can see here, I'm splitting that data. There's that data split. I'm training an algorithm, training a learner with that training data. And then I'm applying that to the test data. And I'm running the experiment just to be able to see the output and how good this model is. And this is essentially what we did with Jabil, right? So they have, instead of Titanic passenger data, they have the data that's coming in from their assembly line steps. We know which components failed, which components passed. We build an algorithm, we build a model around that, and we iterate. So from a process perspective, the data scientist would be working very closely with a subject matter expert. And here, we see the accuracy on that test data. The accuracy is 0.805. So the data scientist, subject matter expert, they're working together and they're saying, OK, how do I improve the accuracy of this model? Do I need to bring in more data? Do I need to do some feature engineering? Do I need to do I need to do more stuff upstream? What are the things that I can do to improve this model? And then keep on iterating until you get a good model. So once this model is created, you can then deploy this. So I'm going to go to my list of experiments and deploy this model. So if I have R code, if I have Python code in a module, this will then be deployed as a web service, as an API. And so this is really the crucial differentiator in order to be able to incorporate this into your end-to-end solution. Because you might have a model. You might have a model that does really well on taking in all this data. You might have some data in some database, and you write some R code, or you might write some Python code, and it predicts whether something's about to fail. But how do you actually get it running in production with data as it's streaming in to be able to make it useful? So by creating this model and deploying it, I now have a REST API on top of Azure, and now I can incorporate with my end-to-end my end-to-end pipeline. And so I'm going to use Excel to be able to demonstrate this. So my favorite people that I like to use are Leonardo DiCaprio and Kate Winslet. And Leonardo DiCaprio, he traveled in third class, male. Let's say he was a little older, 28 years old, no siblings or spouses, no parents or children. He gambled and won his ticket, but let's say his ticket was $7, and he embarked from Southampton. Kate Winslet traveled in first class. She's female. Let's say she was 23, no siblings or spouses, but traveled with her 2 parents. Her first class ticket was $71, and she also embarked from Southampton. So this then goes through the model. You can see Leonardo DiCaprio does not survive. Kate Winslet survives. So if you've seen the movie, you know this is a pretty accurate model here. If you haven't seen the movie, sorry if I ruined it for you. But again, this is what's happening with Jabil, right? So you're sending data from these sensors. It's going to this REST API, and you're getting a response back. In this case, I'm sending characteristics of Titanic passengers. In a manufacturing sense, you're sending sensor data, and then it's coming back. And with this data, you can even do something like in Excel. You can say, being a 28-year-old male traveling in third class apparently doesn't bode very well for you for survivability. So let's upgrade to second class and pay a little bit more for our ticket. Okay, so that doesn't help at all either. But let's say instead of being 28-year-old male, you were a 5-year-old boy, and you can see that it's predicting that you would survive, right? And so now you have the ability to be able to expose your machine learning models in ways that other people can consume it. You have your end client apps, so your end-to-end pipeline, which is sending the data and getting a response back and be able to take action based on that data. Or you can do it in something like Excel. Maybe you have a lot of data. You have some analysts who are looking at the data. They don't know machine learning, but you can build a machine learning model that exposes it so that they can then start doing the what-if analysis on top of this data. And you can see here of all the various ways that you can expose it. And from a Power BI perspective, the end-to-end may look just something like this, right? You might have a dashboard that's hooked up to Azure Stream Analytics, and it's running through a machine learning model. So now, at each assembly line, you can look at the number of items that have been processed. You get a list of the components that are predicted to fail. And once you have that list, you can then go and take action based on that, right? So, so maybe at assembly line step 1, you think that it's going to fail the functional test. So let's scrap it, rework it right here before you put more expensive components on top of it, only to find that it fails in the end, right? So this is really just, at the end of the day, the data that you already have, be able to incorporate it, apply machine learning easily to it, and then be able to make better decisions with it. So you have your hot path dashboard. If you look at the, I think if you look at the solution, we also deploy a Power BI dashboard that then you can hook up to this. So you have your hot path dashboard that does the analytics to be able to show you in real time which components are failing, and a cold path dashboard that shows in various assembly lines, across your various regions, how they're performing over time. And so this is just basically the end-to-end component workflow of being able to process that data. And going back to our slides here. So that was just the machine learning process, right, of being able to apply machine learning to the data that you already have. There's work to be done in terms of figuring out the data that you have, the algorithms that you would apply, and figuring out. But we want to really make it easy for you to have the tooling to be able to apply this. It's simple enough to be able to create a machine learning model, expose it as a REST API. You will have to hook it up to the existing data pipeline that you have, but then really just to get you to value very, very quickly. That's really our end goal. So in terms of some of the ways that, some of the challenges that we faced, working with Jabil, I know I paint a very, very pretty picture of, oh, it's so easy, you have the data that you have, and then you build a machine learning model and look at it, and all of a sudden you save $10 and 10% energy costs. Some of the things that we're facing, one is just imbalanced data, and so you might want to think about various sampling techniques to be able to get a good data set, because if your process is already very good, you might have 10,000 good components and only one bad component, right? And so it's really hard to train a model when you have such imbalanced data. So those are just considerations that you have to have and to be able to do with that. How to split into training and validation sets. And so in this case, again, we have our training set. This is what you get to study, what the algorithm gets to use to be trained, and the validation or the test set, that's what you apply it on. Leakage is when when the data is too correlated, when the data already reveals the answer. And so you might train a model that works very well on the training set and it works well on the test set, but it might fail spectacularly out in the real world. And so this is just another consideration as you're looking through the data to be able to understand whether you're going to have any leakage when you're building your model. And again, this is just what that looks like. And so this is the dashboard examples for something like a speed layer and something like the batch layer to be able to show you, okay, these are the components that I've hit, these are the components that are failing, and then overall what that looks like. In terms of just kind of the takeaways, again, when we went through this process with Jabil to be able to create this solution, the failure data, domain knowledge, like understanding the customer. So again, you being the end users of this, understanding the failure points. I think sometimes we tune out a lot of the complaints and all the pain points and stuff like that, and we just want to get to a solution quickly. But just hearing what their pain points were, just hearing where they were hitting issues, that was a goldmine, a wealth of information that helped us as we built the model. In terms of using existing test systems, again, sometimes you might think, okay, I have this great idea and I'm going to use this and do my predictive modeling, but it's going to require new sensors in place, or it's going to require all this stuff. That scares people, right? People are afraid that they're going to have to start over. But if you have access to that existing data set, if you're able to bring in that data and run it through the model, there's a lot of low-hanging fruit that's available for you to be able to show these results and say, hey, look, this is our existing process. This is how easy we're able to get, identify failures. But if I just apply this model to the same data and I'm able to, find one more failure, make it 10% more accurate, there's a lot of value there in what's already existing. And so again, the motivation of all of this, using machine learning to do the predictive analytics. We talked about at the last session, the types of stories that you can tell with data, right? A lot of stories that we can tell with data are hindsight stories, like what happened, why it happened. From a manufacturing perspective, you might get a report that says, okay, what happened? Well, we had 10 circuit boards that failed their functional test. Not very interesting story. Why did it happen? Well, it seemed like it passed the assembly line step 2, but at the final step, it was because of this component and that component that made it fail. Okay, but the problem is you still have this component, you have this board that has to be scrapped, right? That's not very useful. So how do you use predictive analytics to be able to tell the what will happen story, right? So if you hook these sensors up to your machine learning models and you're able to say, wow, at this step, I believe this is going to fail with this much confidence, and you scrap that, and you get a higher yield at the end. Ultimately, you can tell the how can we make it happen story. The how can we make it happen story is, okay, these are our existing tests. They're all passing at this stage, but for whatever reason, a couple of these are failing. What can we do in this first stage, knowing what we know now, to be able to change the process, change whatever we need to change so that they won't fail the final test, right? You can make things happen and be able to increase yield, be able to save money in that way. And so from an Azure platform component, again, this is a Power BI conference. There's a great tool to be able to visualize all of this, but the whole pipeline is super critical. Everything from data ingestion to data processing to predictive modeling, showing your results on Power BI, using Power BI to do the types of data analysis. The end-to-end is very important. So thinking about how you're going to hook up your existing infrastructure, how you're going to hook up the existing data flows into these various components. And again, as a platform company, we at Microsoft, we want to help you get to that value as quickly as possible so that you spend time doing the high value stuff. You're not spending time figuring out how to set up infrastructure or how to do data ingest and stuff like that. And so just being very, very aware of languages like R and Python, just all the innovations happening in open source. this is a new day at Microsoft. We're not just restricting you to the Microsoft stack anymore. All the stuff that's happening in the Python world, all the stuff that's happening in the R world, you can bring in and incorporate into these solutions. So with that, I want to thank you for your time. And hopefully this gives you an idea of the various frameworks and strategies that you can start with to be able to take the data that you have, incorporate them, and build machine learning models around them to be able to do better from a manufacturing perspective. So thank you. And